To make sure we're ready for what we're going to learn today, let's do a review of how to graph points on a coordinate plane. First of all, what is a coordinate plane? It's like a graph that goes up and down and in all directions with lots of lines and points. Exactly. What else does it have on it? It has an x-axis and a y-axis. Very good. So here's our coordinate plane. The x-axis is going side to side right here, and the y-axis is going up and down here in the middle. So, what kind of numbers are here on the right side of the coordinate plane? Positive numbers. Great job. And then what's on the left side? Negative numbers. Very good. As you can see here, the right side has positive numbers, and the left side has negative numbers. So then what kind of numbers are going up the y-axis? Positive numbers. Great job. And so that means that going down has to be negative numbers. Very good. It seems like you remember a lot about coordinate planes. So now we're going to practice graphing a point. Let's see if we can remember how to do that. So our point that we're going to practice with is 4, 2. Can anybody help me out with that one? Yes, Billy. So, how would I graph the point 4, 2? Well, I can't remember if you would go up 4 and over 2, or over 4 and up 2. That's a pretty common mistake, Billy, or something that people are still learning. But an easy way to remember it is, well, let's see if you can figure it out. Would it be easier to run first and then jump? Or would it be easier if you jumped first and then tried to run in midair? It would make more sense to run first. Exactly. That's how a lot of people remember that on a coordinate plane, whenever you have a point, the first number tells you how far you're going over on the x-axis, and the second number tells you how far up you're going on the y-axis. So for the point 4, 2, we would run 4 spaces. 1, 2, 3, 4, and go up 2. 1, 2. And this right here, this intersection, we'll label with the point 4, 2. Great job, guys. Today we're going to learn some different ways to move shapes around on a coordinate plane. The first is called a translation. Let me write that on the board. Translation. It means to move a whole image in any direction in any distance without changing the dimensions of the image. So you're not going to make it bigger or smaller. Here's an example. This right here is an example of a translation. It takes this triangle right here and it moves it up and over. You can count the coordinating points to see exactly how far it moves. So these are both point B, so let me count. 1, 2, 3, 4, 1, 2, 3. So this triangle has moved up 4 and over 3. Same with point A. 1, 2, 3, 4, 1, 2, 3. And same with point C. 1, 2, 3, 4, 1, 2, 3. So that way you can check to make sure everything is moved exactly the same amount. So if I were doing it with my hand, for example, I could trace my hand right here, move it over and trace it again right here, and that would be a translation. We also have a reflection. So a reflection gives a mirror image of a figure over a certain line. So you can reflect it over the x-axis, you can reflect it over the y-axis, or any other line that you choose, as long as the image on one side is the same as the image on the other side, but flipped. So, for example, this is a reflection right here. So you see this top triangle has been reflected over this dotted line in the middle. So I knew how to reflect it because all the points are the same distance from this line I drew. So you start with this point and go 1, 2, draw a point right here. And then from the top you go 1, 2, and count down 1, 2. And drew the second point right here. From the third point it's 1 space away from the x-axis, or from this line that I drew, and then 1 space on the other side. And so it gives you a nice flipped picture of a reflection. You'll get some more practice drawing your own in a little while. The last one is called rotation. It's when you take the image of the figure and rotate it around a certain point. Oh wait, first let me show you an example of a reflection with my hand. Okay? So I could trace my hands on this side the line was right here. Then if I wanted to reflect my hand, I would trace it on this side. And that way, I would have a mirror image of my hand, if that makes sense. And so, now we'll talk about the third one. The third one is called a rotation. And it's when you take an image and you rotate it around a certain point. So here's this triangle. The original one is just the outline. You can rotate it in any direction and however many degrees you want, and it will still be the same shape. But one point has to stay in the same spot. So on this triangle, this middle point stays the same, but it moves 45 degrees, it moves 90 degrees, then 180 degrees, then 100 and 200 and something degrees, and then all the way back around for 360 degrees. It's 90, 180, 270, 360 degrees. So don't worry, you'll get more practice with that too. But this is just to show you what it is. So if I wanted to rotate my hand, I could just put it down and then pick a point. So I could, let's say I wanted to rotate it around my thumb. I could draw it here and then draw it anywhere that I wanted to, and it would be considered a rotation. But it doesn't matter how much you turn it, as long as one point stays the same. Or I could rotate it around, say, my middle finger. As long as my middle finger stays the same, my hand isn't changing size, and so it's a rotation. So we'll get some more practice making your own in just a little while. Let's see if you can figure out what transformation these real-life figures demonstrate. So look at this checkerboard I have over here. If I take this piece and I move it here, what does that demonstrate? A transformation. Close. What kind of transformation is it? I think it's a translation. You're exactly right, because you're just taking the figure and sliding it over, and that's what a translation is. So now, let's look at this video of a basketball player. We'll watch the video. And so this is a video of a basketball player pivoting. So he's taking his whole body and turning it around his foot, side and side, back and forth, like that. What do you think that represents? Is it a rotation? Great job. You know that because one point is staying still, and his body, which doesn't change, well, I guess he's moving around a little bit, so it's not perfect example, but his foot stays in the same spot, and his body rotates around it. So that's a great example of rotation. It can help you remember what it is. The last one is this butterfly wing. So this is one of the butterfly wings. If this is the other butterfly wing, what do you think that's an example of? Is it a reflection? Great job. You know it's a reflection because both of the butterfly wings are exactly the same, and they're just mirrored across this line in the middle. Like this one, and then you have this one. Yeah. So you can remember butterfly wings as a way of knowing what a reflection is. So now we're going to try with some figures on a coordinate plane. Here are 3 shapes that have been transformed. Let's label their movements together as a class. So, on example 1, right here, what kind of transformation is this? If you take the heart and you slide it over, what is that? That's a translation. Exactly. Let's look at it a little bit closer to see exactly how it moved. So, this first point on the triangle right here is equal to this point on the triangle right here. We'll label them A. A, 1. Okay. So this point is moved to the right 1, 2, 3, 4, 5 points. So in order for it to be a true translation, all of the points have to move the same distance in the same direction. So all of the points should move 5 to the right. So let's check point B. Does it move to 5 to the right? 1, 2, 3, 4, 5. It sure does. In point C, moves 1, 2, 3, 4, 5 points to the right as well. So that's how you know it's a true translation. Let's look at the other ones. This is the next one with the squares, right? Right here. Example 2. So, what do you think that this could be an example of? A reflection. Exactly. What is it reflected over? the dotted line. Great job. Let's make sure that it's the same distance away on both sides of the line, because that's really important for it to be a true reflection. So it has the same shape, right? Yeah. Great. Let's check that out. So you have this first point right here is 1 away from the line, and so is its mirrored point. This point is 2 away from the line, just like its mirrored point. This one is 1, 2, 3 away, just like, you guessed it, its mirrored point. So if you go through and check all of the points on the shape, you'll see that it is truly a great reflection. So we have another one. We have number 3 right here. So it kind of looks like the tip of a pencil. So if you take a pencil, if it's like this, and you rotate it 90 degrees, that just means on its side. Whoop. Actually, it's going the other way. Let's rotate it this way, 90 degrees. What is that an example of? You already told us, it's a rotation. You're right, it did already use that word. But, so let's talk about the degrees. So if you move it all the way upside down like that, that's 180 degrees. Half of that right here is 90 degrees. So it starts at 0 and then it is 90. If we rotate it again, it would be 180. If we rotate it again, it would be 270. Then all the way back up around, it'd be 360 degrees for a complete turn. So those are just some things to keep in mind, but we'll learn more about this later. And so can you tell on example C, on example 3, what point it rotates around? Yeah, you're right. It's this one right here. Great job. So let's look at an example that's a little bit different. So let's look at number 4. Let's take a look at this one. What does this kind of look like? A translation. You're right, it looks like one, so let's test it. So we start with point A right here. Let's see how far it has to move. It moves up 1, 2, 3, up 3, and over 1, 2, oh, yeah, this goes here. Up 3 and over 1, 2, 3, 4. Up 3 and over 4. So let's test the other points. Let's call this point B. Does point B move up 4 and over 3 points? Up 3 and over 4? 1, 2, 3, 1, 2, 3, 4. But wait a minute. That's not point B on this triangle. So point A moves up 3 and over 4, but point B only moves up 1 and over 1, 2, 3, and over 4 points. So here you have 2 points that aren't moving in the same distance and direction. So that way, I mean, just looking at it, you can tell that the second one is bigger. So that means it's not a true translation, or that something else has to happen besides a translation. But, so by comparing the points like that, you have to count how far each point is moved. You can tell if it is or not. So this is something that you want to try to avoid today whenever we're practicing translations, because that could get really tricky whenever we start doing this on purpose. In just a minute, you're going to be making your own series of transformations. So you're going to take a shape and you're going to do 5 different transformations to it to see what the final shape looks like. Let's do one together first, so we can make sure we can know how to do this. So first we're going to write down what our transformations are going to be. So let's write down, and you're going to want to use a different color for each instruction to make sure that you get your shapes and your directions coordinated. So I'm just going to start with the plain triangle, which I'll show you in a second. And then my first instruction is going to be to move it. Let's go up 4, down, well, that is it. Let's go up 4, left 2, down 2. So we're going to start out with the original shape. So this is the original shape. I'm going to move it up 4. So 1, 2, 3, 4 is my first point. Oh wait, sorry. Up 4, left 2, and down 2. So up 4, left 2. Pretend that's not there. Up 4, left 2, and down 2. This is going to be the final stopping point. I'll need to do that for all of the points. So we have the top one, then we have the bottom one. 1, 2, 3, 4. Alright. So if you do that to all of the points, this is what it will look like. And so then we need a next instruction. Let's just reflect it over the x-axis. So I'm going to write that down. Reflect over the x-axis. I'm going to do it in a different color so you can see how it moves. So I'm going to be reflecting this triangle upwards. So if we're reflecting over the line, then I know this point is 1 away from the x-axis. I know this one is 1, 2, 3. 1, 2, 3. And this last one is 1, 2, 3 also. 1, 2, 3. Then I connect the points of my triangle. Color it in. And I have my second movement. So now the third one, I'm going to reflect it over the y-axis now. So write it down. So reflect over the y-axis. So I'm trying to make a mirror image on the other side, so I'm going to count again to make sure that our spacing is right. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And on the other side, 4, 5, 6. And then, since this is a pretty simple triangle, I just know that it's going to be like this. For time's sake, I'm not going to actually count out all the points right now. But that is how you find it for all points. So then you have your third movement. My next one, I'm going to rotate it around point B. So I'll draw point B. I'm going to rotate it, and on this one it doesn't matter how many degrees you rotate it, just as long as you get it done. So 4, rotate over point B. So I need to label point B, which I've got, and then I'll need to rotate around point, which I'll show you what it looks like. This is what it looks like to me. So you can see I wrote it on the side, rotate around point B. It's this gray triangle right there. So that's my third one. So now I need one more. And I think I'm going to do another reflection, or another translation. So I'm going to move it up 3, right 1. So on each point of my triangle, I'm going to move each point up 3 and right 1. 1, 2, 3, 4. And it will end up looking like this. So, now it's going to be your turn. So what we're going to do is make your own series of 5 transformations on a graph paper that I'm going to give you, and you're going to use a right triangle just to keep it simple, just like mine that I showed you. So, remember to write each instruction in a different color, and it's going to coordinate with the color of your transformed triangle. There's going to be markers and graph paper on your desk already. I actually think that if you want to, if you're not really sure, you can do it in pencil first and then go trace it in markers in case you need to correct it. Now that you're all working on your assignment, I'm going to walk around the room and see how you're doing. Okay, so here's one student working, and this student right now is drawing a reflection that is too close to the axis he drew it over. So, hey Billy, let's check your reflection together, point by point. So point A A on this first triangle is how many spaces from the x-axis? It's 3 spaces away. Now how far is point A on your second triangle? It's only 2 spaces away. Oops, I think I started drawing it too close. That's okay, you're doing great. It's easy in reflections to just want to make the figure you're drawing look like the mirror image, but we need to be careful that it's in the right position too. Let me know if you have any questions. And so now, walking around the room, and then I have a student with their hand up. Teacher, how can I draw this triangle in 2 colors? You won't be able to see the steps. What has happened is she has rotated over the x-axis, and then over the x-axis again, and then back over. So her instructions were repetitive, but that's not by any means a bad thing. So this is what I would tell her. I would say, wow, I really like what you discovered. If you reflect an image twice over the same axis, you'll end up with what you started with. That's a really creative experimental thinking. Way to try something new. What I would do is just make the second triangle you drew in the same place, maybe have a dotted line or just outline the other triangle. As long as you can see it and I can see it, it doesn't matter, just whatever works best for you. So at the end of the lesson, I would need to sum up the terminology and the concept that we learned today. So I would tell them to pull out our math journals, and so we can write down the words that we remember today, and format and whatnot is not important. And it's just as long as you have the word and just a short picture, just whatever helps them remember, because this is their resource. So I'd say let's pull out our math journals in case you need to add anything. How do y'all feel about the new material we learned today? Hopefully they would say great. And so I would ask them if we could list all three types of transformations that we learned. We learned translations, and reflections, and rotations. Awesome! How does a translation move? It moves straight in any direction. What about a rotation? A rotation moves around a point that stays in the same place while the rest of the shape moves around it. And what about a reflection? How does that one move? A reflection is mirrored across the line or axis. Great job. So what happens, do you remember, if we have a shape, 2 shapes on a coordinate plane, but one of them is bigger than the other, is that right? Or if it's maybe a different shape a little bit, or is it quite the same? No, that's not okay. Why not? Because in transformations, this shape has to stay congruent. Great job. So can anyone think of a real-life example of a translation? Earlier we said like playing checkers. What else can we think of? Driving a car, because the car stays the same and it just moves in a straight direction. Well, in any direction. Absolutely. What about a rotation? Can we think of another example for that? Well, like the car example you said, like the wheels on a car turn in a circle and the middle stays in the same place. Does that count? That's a great example. I like that you kept the car in mind. So what about a reflection? What do you think of for that? Well, maybe it's kind of obvious, but like, is looking in a mirror a reflection? It absolutely is. That's a really easy way to remember what a reflection is. So whatever you need to do to remember what those things are, as long as they're accurate, that works for me. It's simple, but it works. So tomorrow, we are going to be adding dilations, and that's when we'll learn if we make a shape bigger or smaller, or maybe you can move it up and over and flip it and dilate it, and it stays congruent, and it's great. So just be getting tuned for that. Make sure, I hope you have a good rest of your day, and that when you go home, you can tell your parents all about what you learned today in class. Thank you.